they don't have important systems and study. You see, sometimes they create rice where they find so they and and they adapted yearly. So what are the classification of temporary bond ecosystems? So they are mostly classified in using different criteria, including based on the origin. Some are natural and some are man-made. Like for example, maybe you are moving from Arusha going to Babati, you find there are a lot of temporary wetlands along the way because they are made during the road construction. And some are classified based on size. Some are very small and some are very large, even can be several hectares. And some are classified based on salinity, some are freshwater and some are blackish or saline ponds. But one of the main characteristics that define temporary pond ecosystem is hydro regime. So they are most classified depending on the hydro regime. At what time do they receive water, the length that they hold water, that is the hydro period, the timing that they receive water, and the predictability of the inundation. Because some, they are frequently inundated, but some maybe they can even stay for 9 to 10 years, and then they receive just water maybe in 1 year, in some of 10 years. So in this slide, I'm just showing you different classification of temporary ponds according to the hydro regime. So there are some are very ephemeral, some are permanent. So some they can hold even water for almost 9 years, and maybe in just 1 year it's dry. But some are very ephemeral, like the low pools, they just hold water for maybe 2 or 3 days depending on the climatic condition. And in this slide, I'm just showing you how these different temporary ponds, they hold water in terms of pond permanence gradients. So you can see from there, the pond that is shown, these are the ephemeral ones, that they just hold water for some days. And there are some that are seasonal, they can just hold water during the rain season, and in the dry season they dry. And some are semi-permanent, so they can hold water maybe for years, they dry out. So let us look on the water balance of these temporary wetland systems. So most of them, they depend on the precipitation to receive water. In some areas, snow melt or groundwater transpiration, seepage, and outflow. All of this water balance is actually influenced by climate, including temperature, rainfall, and wind patterns, but also the topography and hydrology of the region, especially the basic morphometry, the soil permeability, and the groundwater table. So someone might be asking, so how are these organisms surviving in this temporary aquatic ecosystem? So there are several different strategies that the organisms they use to survive in this temporary aquatic ecosystem. So we have different groups, we have 3 groups. I'm going now to present the first group, that's the one that we call the wet season liquids or migrants. So this one, they are alive in this temporary wetland system to reproduce. So they oviposite in water, and after they have grown, they migrate to other permanent freshwater ecosystem. So we have the second group that they visit these temporary wetlands during the dry season. They oviposite in the dry basin, so their oviposition is independent of water, and they're also capable of active dispersal. And these they include different types of invertebrates, including the dragonflies, the cat's fly, and some dipterans. And we have the permanent dwellers, the fresh shrimps, the crane shrimp, and so forth. So these ones, they depend mostly to live in this temporary wetland system. So how do they tolerate? They tolerate this desiccation by producing resistant stages, including the eggs and the cyst. Or some they burrow down into the pool segment. And these eggs and cysts, they stay in the segment long enough to allow them to reproduce when the second inundation comes. So these they include the flatworm, the gray shrimps, the tadpole, and so forth. And now I'm going just to show you some of the resistant stages in different temporary ecosystem dwellers. Like this one are the cysts for the plants. This one are for the rotifers, the eggs for the rotifers. This one are for the cradocellans, they produce the eggs that they can resist the desiccation. And these are for the fresh shrimps, also they produce eggs. And one of the notable fish that dwells in temporary wetland is the killfish. Even we have them in Tanzania. They are very colorful, they are very beautiful. They also produce resistant eggs that they can just stay long in a dry segment and just until the next inundation comes. And here I'm just going to demonstrate just in a picture format on how these temporary wetlands they are inundated and how these organisms they thrive in this temporary aquatic ecosystem. So you find here, I show this is our pool, and these are the segments, and you have the resting stage of the resistant eggs. And then when the water comes, these head they hatch and they produce the organism. And then later the migrants they come because they want either to feed and also to produce eggs in this ecosystem. But then after the hydro period have gone, the migrants will move and go out, and the permanent dwellers they will produce the resting egg banks, and then the cycle continue like that. So this is what is happening that I was explaining. Like this one are the permanent. The migrants they will come later during the inundation. Like most of them they are not migrants, but still they can use passive dispersal mechanism as a means of migrating from one temporary pool to another. And this means maybe when you are passing through the temporary pool, or maybe when you are driving your car and so forth, this can be a means of passive movement from one pond ecosystem to another. But also, these are permanent dwellers. It means most of them, when they produce these resting eggs, they don't hatch all the eggs when the inundation comes. So some they hatch it in batches, and this is called a batch hatching. So it depends on the characteristics of the environmental condition of those temporary pond ecosystem. If the environmental conditions are good, most of the eggs they will hatch. But if the temporary conditions are not good, some of the egg will hatch and some they won't hatch. So that means don't put all the egg in one basket. You never know what will happen next. So this is one of the studies that was conducted in Australia and a Randolph lab. That they were trying to see the changes in population along the longitudinal aridity gradient in southwest Australia. And what they found is like most of the egg were not hatched during the first inundation. So following the second inundation, some of the eggs were hatched, as you can see it from these graphs. And just to cement what I've been talking on, the time travel on dormant egg seed bank, this is what is happening in the temporary pool ecosystem. So sometimes they can accumulate dormant stages of different species in the segment, and they make it to coexist for a long time, and even to have more species and genotype at different times of the stages. And I will just demonstrate this using this pictorial graph on how they produce the resting eggs and how they produce it in different times. So you can see, maybe assume this is species 1, now it's producing the resting eggs, and then later species 2 comes, also is adding another eggs in the segment, and then this is species 3 comes and is adding another eggs in the segment. So in doing this, they make sure like they coexist in this ecosystem, but also they can be able to tolerate some of the environmental condition and harsh environment in this ecosystem, including climate change, human disturbance, and so forth. So the community structuring factors. So in temporary wetland system, there are a lot of factors that they influence the community structure in this temporary wetland system. And in a nutshell, a temporary wetland system, sometimes they occur as an island in a landscape. So we might find there are several temporary wetland systems just connected, like within one landscape. And this may be from our landscape and basin, like in the locals, maybe we can find them in Mwanza, but also even in Arusha and in Babati and so other areas, you'll find some of the temporary wetlands in our system. So they can just be connected in one landscape. And there are several factors that they influence temporary wetland system, including abiotic and abiotic factors. I don't know if you can read most of them from the PPT, but there are several, including temperature, salinity, pollution, and so forth. And for the abiotic factor, they include interaction between one organism to another, and so forth. But one of the important structuring factors in temporary aquatic ecosystem is the hydro regime. This is the most important factor because it introduces the time stress in these freshwater ecosystems. So if you find in most cases, if the temporary wetland ecosystem is big enough, you will find species richness is high. And if it can hold water for quite some time, also the species richness increases. And this also can be just explained by this picture. Like the richness increases with hydro period and the inundation frequency. So in most cases, most of the temporary wetland that they receive frequent inundation, they will have higher richness compared to the one that maybe they receive inundation once in a year or maybe once in 5 years. So these are some of the key local community structuring factors, including the pond surface, as I've explained. So the higher the pond surface, sometimes it can have more species richness, the salinity, this can cause osmotic stress, the nutrient level, the trophic status, macrophyte cover that can provide microhabitat, food and shelter to the inhabitants in the temporary wetlands, but also the competition between species within the temporary wetland system, including maybe the filter feeder, they compete for food. And this is one of the examples of the study that was done in South Africa on the pond permanence. And so if the pond was more ephemeral, going to the long one, like the ephemeral pond, they had relative lower species richness compared to the pond that they hold water for quite a long time. And this can be seen from the graph. The yellow means a long time, and the E means the ephemeral one. So the ephemeral one, they had relative lower species richness compared to the pond that they hold water for quite a long time. And this is another example on the abiotic factors, and this was done on the salinity influence. So the higher the salinity, it means the lower the species richness, and also the hydro period means the length that the water is being held in the temporary wetland system. It also supports the higher the species richness. So if you have the pond that they hold water for quite some time, it means even the migrant will come and you'll find they will have higher species richness. But if you find the pond that they have higher salinity, sometimes it's negative affect the species richness and composition. And this also is one of the examples of anthropogenic factors, apart from the normal local factors. on how they influence species in temporary wetland systems. So most of the anthropogenic impact they affect indirect through changes of local habitat characteristics. It might be changing in the water, nutrients, changing in microphyte cover, and so forth. And also this is the same. And here we say that the anthropogenic impact depends on type of temporary use, because the temporary aquatic ecosystem, they are used for different purposes. If they are used for recreation, most of them, they will have even a lower anthropogenic impact. But if maybe they are using for crop culturing, their drainage, it means the anthropogenic impact will be higher, and thus will affect more the species richness in these temporary aquatic systems. So why are these temporary ponds important? Of course, maybe we are used to see the lakes, the rivers, and so forth, but temporary aquatic ecosystems, they are very important, both ecologically and in socio-economic value. So they have a lot of socio-economic value, including their water purification, buffer against flooding, and so forth, groundwater recharge. They are breeding sites for most cattle and wildlife. They are nesting areas, and even they have cultural and aesthetic values, because in some region they use this temporary wetland system, even for, they go there people to worship, even they have educational value, like the scientific value, like now we start them, we know what they hold, and how maybe even they interact with other permanent freshwater ecosystem in the region. However, these are one of most neglected freshwater ecosystem in the worldwide. Sometimes maybe because of their small size, or maybe of the negative perception of most of the community. So what are the threats that the temporary wetland system they receive? So there are several threats, include habitat destruction, hydrological modification, unsustainable land use changes, pollution, and invasive species. And this can just be described in one of these pictures. We can see there is a drainage, there is an urbanization. It means the rural aquatic ecosystem, they are changed to another use. But even waste disposal, because somewhere they can use to dispose waste in this temporary wetland ecosystem. But also climate change influences another threat to this temporary aquatic ecosystem, because it influences the hydro regime of this temporary aquatic ecosystem. And this they influence their acidification that causes a shorter, less predictable hydro periods. So what do we foresee when with all of these human-induced influence in climate change? So most of the temporary wetland ecosystem, they can be fragmented, because as I said, they occur like islands in the landscape. So it means if they are converted or they are changed to other use, they can be disconnected, and this will influence the species, community occurrence, even the dispersal, and the species diversity, and so forth. But with climate change also, it means there will be frequent Spain, in US, you can see the percentage, and in Portugal and in Morocco. Unfortunately, we don't have data for East Africa compared to the permanent one. But you can see how they are lost in different climatic zones. And this is one of the studies that was done in northwest Morocco. As you can see, here you can see how many species were lost within the same temporary wetlands. And only two species. So they are highly threatened, and most of the species they are we don't don't know much what is happening in this temporary aquatic ecosystem. So if this is the same also in the study that was done in Morocco that showed the threats and how this temporary wetland ecosystem, they are disappearing with time. So why is this happening? In most cases, from the studies, it's from perception, because most of the temporary aquatic ecosystem, they are perceived not to be important. Like in our region, if someone atakutana na pond atasema kwamba linasababisha nini, malaria, tufukie na kila kitu. But from the study that Mataba presented yesterday, it shows like not all the ponds, they hold mosquitoes that they transmit malaria. So this should be aware, like we should provide awareness to the community, like this temporary wetland ecosystem, they are very important. Even they support biodiversity, the regional biodiversity, they host most important micro and macroorganisms, which are very key in the ecosystem. But because we don't understand, we just think like most of them, they are just mazalia ya mbu, and which is not correct. So what to be done? So we should have a holistic approach on how we can conserve this temporary aquatic ecosystem. These include the administration part of it, and the scientists and the users. So the users, they should know the importance of this and do some conservation measures. But for the scientists, we have to study them, we have to know what is happening in this system and how maybe we can inform even the administration, the police and decision makers on the importance of this freshwater ecosystem, especially on the landscape, and even how they support the hydrology and how they support other freshwater ecosystem in the region. And apart from that, also we can do some restoration measures which have been done in some several European countries, including Belgium, where they try to restore the temporary wetland system to support the biodiversity and so forth. So in conclusion, what I can say, temporary ponds, they are island in space and time, and they inhabit very diverse and unique flora and fauna, and they are mostly classified, or they are most influenced by hydro regime, which is the key factor structuring the communities. With the climate change and land use changes, these habitats will become more isolated, both in space and time, leading to the loss of their unique inhabitants. So next time when you are out and you see a temporary pond, you can have your net and try to see what they have inside, and even you can share with the community, with the family, and just to share the value and the beauty of this temporary aquatic ecosystem. So to this end, thank you so much for listening, and Chair, back to you.
Thank you very much, Dr. Nielsen. That was fantastic. Again, if you would like to welcome me, join me on the stage. And we'll have plenty of time for Q&A. Again, thank you for the three presentations. It was an interesting session looking at ICT, looking at the role of agroforestry, all these relatively small activities. So I'm sure you'll be fleeting questions to answer all questions. Hands up, please, and I might draw five. 1, 2, 3, 4, 5. Okay, we'll take that as 5.
Good morning, everyone. I would like first to commend the presentations which you are put forward this morning. I have a small question to the last presenter. You said that
to enhance these temporary ponds to become permanent ponds based on their significance in terms of biodiversity conservation, but also the human use. Thank you. Thank you. I would like to congratulate all the presenters. And my question goes to Professor Ida. I appreciate the presentation. Everything mentioned are valuable. But I have some worries in change of these agroecology systems in the practice of farmers. Smallholder farmers are these days making change, especially in our case, for example, in Ethiopia. Precious export commodity for the country by chat or some chat kind of stimulant, which is actually it is a cash crop. It's going to be replaced. So what kind of policy advice do you give for this kind of activities? Okay, my question. And the other one is for the last speaker, delegate of Professor Luke. I have seen the temporary ponds are valuable ones, and also even the permanent ones are also very well studied. And they are considered to be also the lungs of these water bodies. As you mentioned, a lot of things are there. But when I see things are changing these days, they are making a lot of investments to the lake shores. Even the permanent ponds are disappearing than the temporary ones. The temporary ones are, as you mentioned, they are considered to be a source of mosquitoes and malaria. So they are trying, even in public media, they are advocating that to remove or to end these temporary waters, to avoid these temporary waters to protect malaria. So what do you advise for example, specifically buffering zones? How it should be the distance for these permanent lakes or reservoirs to be conserved as a wetland? Thank you very much.
Thank you very much for the nice presentations, Prof. Ngolube. Sometimes I have the impression that social networks are interfering with the social interactions of people. So for me, pubs are the real social networks, and sometimes I have the impression that people become asocial due to these social networks, the ICT applications like the apps. So my question is, just to challenge you, so what is the current organization of the farmers, and how do they exchange currently the information, and how the introduction of these apps can interfere with the traditional exchange of information and organization of the farmers? Thank you.
One more? Yes, we'll take one more. Yeah.
Thank you very much. My name is Akida. My question goes to, I think, the first two presenters. So number one is to Professor who presented this is on ICT. And then, yes, Global. So I was wondering, when you were sharing with us the experience from M-Farm from Kenya, that the system was able to reduce the chemical fertilizer usage, and then at the same time was able to improve yield by 50%. And the question was, how was it possible? And then number two is like a recommendation that we know the importance of the contribution of the ICT in improving land productivity. But I went through some experiences that at some point, some of the technologies, it's like when they were developed, there was no clear consultations with people maybe from respective fields, in a way that at some point they are misleading farmers. So they are contributing to some point to degrade land. So the suggestion is when developing, think of interacting with respective people to be able to contribute to their expertise. And then my second contribution goes to Professor Kimaro. That if you go around the Mount Meru and Mount Kilimanjaro, you find there is a very fast movement in terms of farming system transformation, especially with this young generation, that they are cutting down trees and then they replace with more or less shade-tolerant crops. I think for them they want to make more money. But I've seen that in a few years, those farmers are abandoning the land because it cannot produce anymore. So, which policy do you think can be put in place to make sure that we protect the nature?
Thank you very much. Well, we have 6 questions. That's quite a lot. We'll see if we get quick responses, and we may come for another round.
All right.
Okay. So we'll do it in reverse order. So, Greta, you go first, and then we'll go back across the line.
Okay. Thank you so much. So I'll start with a question from Professor Rugumela that he asked about, saying like the species are disappearing, but there are some new ponds have been made. Yeah, and then your question is like maybe there are some species are emerging. But to look at the temporary wetland and temporary ponds, most of the species, especially the permanent dwellers, they are not active dispersers. They are not. So it means they depend on either human interaction or animals that to move them from where they are to the new ponds. And that one even can take years. So it depends on the new ponds, where are they located and how far are they from the permanent one. And what is the condition of the permanent pond at that time? Do they have a species? The environmental conditions are good for them to hatch and so forth. So for the new ponds that have been made, like the one that are made not purposely, like the one I just gave an example from along the road when they're constructing the road. Sometimes you might go there, you don't find any species, or just find a few species because of the environmental condition of that pond, and also which one have now the pond dwellers have come just to find habitat and shelter in that. So even when we are going to do pond restoration, of course it's good also to consider where they are naturally occurring, and then maybe we can enhance the restoration. And if maybe we do in other landscape, like if we do restoration in other landscape, also we should consider the issues of dispersal and the colonization of these species to these new ponds. I think I've answered your question. And also I can give an example, like for the stud or restoration stud that have been done in Belgium. I remember there were some species, including the mollusks, even the fair shrimp, where they didn't recolonize like for more than 5 or 10 years. So it takes time for them to recolonize. So it means if maybe we are going to destroy the one that are permanent, we might even be losing the species without knowing, even if we are going to do restoration in other landscape. And for Kisi, for the rotifers, I think at some point I mentioned rotifers in one of the pictures with the egg banks of the rotifers. Of course they are permanent. I didn't mention every species, but I was just mentioning groups of the species that are found in temporary wetlands. So they are there and I acknowledge them, so it's not like they are not there. But I remember, like I just showed a picture of the eggs of, I think, of the lotifers in one of my slides when I was presenting. And okay, for the Bernard, you are saying like maybe we can enhance this temporary pond to be the permanent one. This is not advisable, no, at all, because if you enhance this one, it means now you are going to change the environmental condition to be the permanent water bodies, and means the permanent dweller that they are used, or maybe they are used with this drying phase and inundation, they will disappear because the environmental condition won't suit them to be there. So they are supposed to be like that to include the diversity, diversity and biological diversity, I can say. So if you change them to be the permanent one, it means you are going to change the characteristics of these ponds, and even the species that were coming here as refugees, who they are permanent dwellers here, now they are going to disappear, and then we won't have them. And for my friend from Ethiopia, you were saying like there are campaigns like to maybe to not to keep these temporary ponds. Of course, that is what is happening in most African countries. And that's why I said in one of my slides that we have to bring now awareness on the importance of this temporary wetland system, and maybe probably also they should be recognized, especially at higher levels in the police and with managers like the basin authorities and so forth, in terms when they are doing their campaigns in freshwater ecosystem management, they should include these small water bodies, because in actual sense they help in hydrology, they help in flood regulations, even they host some of the key species. One of my studies which I did in temporary wetland system, I was looking on the interaction of temporary wetland system with the river ecosystem. And we found that some of the temporary, flood-prone temporary wetland system, they are used by fish to go there and to, like for the small fishes, they go there and they hatch their eggs. And after some time, when prohibited to do human activities from the freshwater sources. But also this one has to be looked at, because you can't say all of the freshwater ecosystem 60 meters is enough. Some is supposed to be even 2 kilometers, some is supposed to be 100 meters, some is supposed to be 50 meters, depending on where they are, the importance, and what are the ecosystem functioning, and their key ecological function in the region. So even 60 meters, like you can find, like for the Lake Victoria, is not enough. That's why you find even there are a lot of pollution and so forth. But for small water bodies, 6 meters can work. But for big water bodies, sometimes it doesn't work. So it depending on where these freshwater ecosystems they are found, and how important they are, and what are they used for. Because some even they hold keystone species, some they are very peculiar, they are species they have, they are not found in other regions. So it means they are supposed to be protected, it can be different. So this also turns into a police reformation. So we have to reform the police. Like 6 meters can't apply to all the freshwater ecosystems. So it depends on their functioning and their importance in the region.
Thank you very much for very comprehensive answers. Adidas, maybe you're next to just do it. Okay, yeah,
okay, thank you. Thank you for the two observations. Yes, I agree with Ashanafi that we have worries are there, and we have a lot to worry about. The degradation of these systems. And first of all, for us as researchers, that is why we are calling for actions that we need to take. If you look carefully into these systems, for example, if I can take the case of Ethiopia, of course, the case of Mount Meru and Kilimanjaro, which also Akida pointed out, the motivation for sustainability was the coffee. So there was an economic value which was driving the sustainability. It was a shade, coffee required shade of the trees, and in particular the native trees. Now, coffee had some challenges, including the coffee berry disease, the leaf rust, productivity went down. So that motivation started shaking. But again, the global coffee prices, coffee market, that was a major cause for forcing the pharmacy to change the direction. Now, for us, so such factors are likely to enhance or to accelerate the dynamics. So for us as researchers now, we need to think of an alternative economic model integrated into the system, which will bring the farmers or the communities into an equilibrium. That's why we need to research on these trees. We are researching on carbon stocks, what the trees can store above the ground, what the trees can store below the ground. And if we can say tree A, B, C, D are potential for mitigating and adapting to climate change, we can attach market value to it, and we can create a kind of payment of ecosystem services. So, and in that way, will bring the communities again back to the sustainability of the system. There are many other business or market or economic models we can see. Non-forestry products. For example, in Kilimanjaro now we are researching on some farmers, they are practicing on stingless bees. They don't bite, they are friendly, but a liter of stingless bee honey in Kilimanjaro costs 40,000 Tanzanian shillings. If you divide it by 2,500, you can see how much euro is that. So we are promoting that as a non-forestry product, which can bring a kind of an alternative economic value into the system. We as researchers, we need to develop other business models integrated within the system. For example, agritourism. If we can make these native trees and the whole system that is a tourism product, that one also can be an alternative economic model which can sustain the landscape. But we need to create awareness as well. Once we have all the data set, we have correct results, which we can disseminate it to extension staff, we can disseminate it, we can share with the NGOs, we can share with the policymakers, we can come up with a kind of balance method how to bring our results into the ultimate communities. Right now, okay, we campaign for planting trees. And Professor Karin is here, can testify that. We have seen even extension officers bringing pine into these agricultural lands, bringing eucalyptus into these agricultural lands. And she can tell what damage pine can do in the agricultural landscape, which is stay there for some. So we need to create awareness, first of all, among ourselves, the scientists, the extensions, the extension staff, the NGOs, because the NGOs also, they want quick results. They want quick results, and they want it to be heard by the policy makers. So they can just promote anything. So if I can say now for the policy, that is what we needed to do. First of all, researchers to submit correct results to the policymakers, to all the stakeholders, and find a platform where we can then direct what to do, bringing the pharmacy into the platform. And in that way, I think. So here we have two. We have recommendation for researchers, and we have recommendation for extension staff. We have recommendation for policymakers. Thank you.
Thank you very much. Lastly but not leastly, some interesting thoughts about pubs and ICT and social networking.
Thank you very much for your questions. I think there are about 3 of them. Yes, I agree with you. Human beings are naturally social beings, and at times technology can make them antisocial. We have seen that even with simple technologies like cell phones. You find people that are together in dinner and people are busy punching on their smartphones and so forth. But however, in this case, technology does not really make or does not break down those social ties. If anything, technology brings hard to get, hard to reach information close to the social networks. So say information from satellites, images from satellites, for example, images from satellites, they can actually help manage plant growth, soil fertility, and all that. So that information is translated into a language which can be communicated to the local people through local radio stations, for example. So radio stations are interactive. They also foster some kind of interaction. More than that, the extension workers also, they get all this information and then they spread it to the people either through workshops, clubs, and etc. So that social interaction is not really killed or destroyed by ICTs. If anything, ICTs, they become a bridge to the hard to get information and what is happening on the ground. So we are able to share the information that is available with all these high-tech technologies that are available to the ordinary person in their own language on the ground using ICTs. So I agree with you that we don't have to remove the human being in the technology. We shouldn't lose our social being in the technology. And I don't think that's what technology is about to do. I know that there are a lot of things happening in technology, and some of them, they are very scary if you come to think of the artificial intelligence and all the robots and all that. But I want to think that the human being and human interaction will always remain important, because there are things and there are areas where the technology will always fall short of that human touch. So I don't foresee in my lifetime where technology will be able to replace that social interaction. So don't be scared. You are still safe. You will be able to interact socially, and the networks are going to be there. You remember I even talked of the Uganda women network. They use the technology to share information in that network. So that there is a network already, it shows that there is an element of interaction. So if there is anything more that you want us to do, we can continue being social during tea time, and then we can have more ideas around that. And coming to your interesting question, yes, you saying that it's actually funny that I say that the use of technology led to the reduction of the use of fertilizers. And at the same time, there was an increase of productivity, and that sounds like a contradiction. And we say, how is that? So what happens therefore is that fertilizers, I think one of the speakers even mentioned it, fertilizers actually, they are not good for the soil. I'm not really a scientist, but fertilizers destroy the planet. So what then are these mobile farming technology does is it raises awareness on the importance of using renewable energy like manure and other energies that are available. So people are even, those who thought that fertilizers are expensive and they are hard to reach, they are now convinced that if they are not only expensive, but they are only destructive, they are also destructive to the environment. Therefore, we must have alternative energy, alternative ways of fertilizing our soil, which is the ways that we have around us. So it's going back to the source to say that they also get the fertilizers and they use things like manure and etc. And that way, the crops will still have a high yield without fertilizers. And coming to the last point where you say that technologies tend at times to mislead farmers because we create these technologies without actually checking with you farmers to say, how do you really need that kind of technology? Unfortunately, with technology, yes, at times we build it and we think that we are going to use it. But what happens is that if you looked at my approach was not high-tech. I would have actually gone very high-tech and gone into all these new technologies of robots and drones. But I tried to show you that these are inappropriate in the context of the farmers. These can be used at high-level interactions, policymakers, people in the offices like yourself, researchers. Then you cascade that information that you get from these high-tech technologies using very simple technologies like radio. And I don't want to think that you think that a technology like a community radio station would mislead a farmer. That is the technology that they are used to. The cell phone, I don't know whether in the cell phone penetration in Kenya or other countries like Tanzania is as high as other countries like South Africa, because in South Africa I find even a grandmother in the village, they do have a cell phone. They may not have the most sophisticated cell phones, but they do have cell phones that can send and receive SMSs. So what we are saying therefore is that much as these high-tech technologies are important, and we cannot do away with them. We cannot do away with the satellite images. We cannot do away with sensors. They bring information to us in many ways than one. And then we harness that information and we package it in a hybrid mode and make it available, for example, through community radio stations and cell phone technology. And in that way, we are not really very far from the farmers. Your recommendation is actually taken to heart that we should actually consider the people that we are actually developing the technologies for. But at the same time, my presentation tries to show that the bridge is there because we kind of say these technologies we can't do without them. We need that information that they transmit. Much as our local people may not understand or may not be digitally literate to actually use them and interact with them, but the information is available in the way that they can understand it through using the hybrid approach. Thank you.
Thank you very much. Unfortunately, I don't think we have time for another round of questions, but if you have a burning question, please raise it at the break. We're 15 minutes over already, and in the grand scheme of things, that's not too much, but I think it's important to be social and go and have tea and coffee. I would really like to thank three excellent presentations, excellent responses to the questions. So just
Thank you.
Thank you. So. With a very special appreciation to Professor O for moderating session 1. Now I have one announcement, maybe one or two. The first one is we will go for break, and after that we'll be splitting up into 2 sessions. I'll come to this later. But as we take our coffee, who has the poster presentation and should be making the presentation over there at the entrance. So you can visit Benedetta, and she will take you through her poster. We happen to have just one poster presentation, so he standing by the poster and ready to take you through. And the other announcement is that we are going for coffee, as I said, and after that we'll be splitting into 2 sessions as we use it to do. In the main venue, I will remain with Letan Molel, Uwi Tonze, Isaiah Mbwale, Asha Kiunga, Kimberly Otieno, and Shekina Hendai. They mentioned they will remain in this venue, and we use this just one day. Oh, okay. So I'm told we don't need to split up into the 2 venues. So everything will be done here. So thank you very much. I wish you. I welcome you for the coffee behind the curtain. Thank you.
much, Florence. Please remain on the stage. Thank you also for saving 2 minutes. Welcome all presenter. Please take a seat. And also let me now open this session for discussion through question and answers. May I see questions? Please raise your hand. I have 1, 2, thank you. 3, thank you. We have 3 questions. Please assist.
Thank you very much.
Be brief and straight to the point.
Yes, okay,
We have 15 minutes of discussion.
Okay. I would have a very short question for the last presenter, Florence. In general, all of you, I would like to congratulate for your nice presentation. Having said this, you came up with an interesting topic, which is identifying on these medicinal plants in pastoralist areas and smallholder areas. But I recommend you just, if I were you, I want to prioritize than determining 10 from each side, 10 individual soft trees. Why not you prioritize with the participation of pastoralists just to identify the most valuable species of trees to be used maybe for human medicinal purpose and also for their livestock.
Yes, my question goes to Sister Isiani. I wanted to know about the agroforestry, which you termed as the indigenous agroforestry system. Is that a new system within agroforestry? Because I had never heard about the indigenous agroforestry system. And if it's so, is that documented anywhere? That is a new agroforestry system, the indigenous one. And the second question is about how long have you collected the data to come up with the conclusion on the accumulation of the soil status, that is to come up with the conclusions. I mean years.
My name is Ida. Congratulations to all presenters. I have questions for 2 presenters. Number 1 is to Sister. I wanted to know if you managed to quantify the amount of leaf litters per year. And then if yes, how much does it contribute to the in-situ soil organic carbon accumulation? And then number 2, how is the observed information is linked to the sustainability of the farming system? And then the question to Isaiah. You did your research in Kikwe and Kisongo words, of which, if I'm correct, they are lying on the same attitude. And I'm wondering, what was the motive for you to include temperature and rainfall parameters in the correlation analysis? Thank you.
Thank you for the nice presentation. Also great the young presenters to stand there confidently. Nice to see. My question goes to Florence. So we want to make use of the local traditional knowledge to develop conservation. Okay. So to develop conservation strategies. So my question is, will your conservation strategies not be biased then towards the conservation of mainly plants in your case that are of socio-economic importance, while ignoring other species that might also be important for the ecological system? So if I would translate that, for example, to animals, if you would do the same study, people would be mainly living fish, but they will forget the animals the fish are preying on. So the total knowledge is needed, I think, to have integrated and sustainable conservation measures. So what is your opinion?
Okay, thank you very much for a very good question. Now I'll invite presenters to respond. Who may start?
Thank you for your good questions. I start for the one who asked which type of agroforestry system did I investigate. We know that we have different agroforestry systems, and so for my case, I investigated the Kihamba agroforestry system. And Kihamba agroforestry system contains different indigenous native tree species. And my study was done in Kirema Central Ward. You can ask, why did you choose Kirema Central Ward? This is because after doing a survey along the landscape of Mount Kilimanjaro, we found that the Kirema Central Ward is one which still practicing these agroforestry systems, because as we go up, the characteristics of this system changes. So we come out to select this for our study. So I'm going to give my answers, but my colleagues are here. If the answers will not be sufficient, they can add. So, Mr. Ford, please, if you can add something.
Brief and straight to the point, please.
Okay, thank you. Actually, Sister explained very well. First of all, this Kihamba is qualified indigenous because of its position of these indigenous tree species, natives and non-natives, but some of them also are very indigenous. But also it has been practiced for almost 800 years ago, and FAO had to recognize it as one of the global important heritage system. So this is some of the characteristics makes it qualified for that. There was another question.
The other questions asked how long did I collected the data so as to come up the conclusion of the data which I have presented.
Of course, based on the research question, we wanted to see the contribution of season on this leaf litter in terms of soil chemical properties, and we had to select seasons, 3 seasons, and we moved with the climatic season we have in the landscape, the high rainfall season, Masika, the short rain season, the Voli, and of course somehow we have in between the dry season. This is how we collected our data, and what we do after oven dried, we had to correlate them with tree species characteristics, and then to see which season had played a major role or vital in soil chemical properties. So we did some correlations.
Thank you.
There is the question which was asking about the quantity per year. I think you have got the answers. We didn't collect the data per year, but per season. The other questions was about the observation of the information that lead to the sustainability of agriculture, I think. So as we have seen the characteristics of those three species which have selected, we observe that they can be used because they have those characteristics which can protect the environment first, but also for increasing the soil fertility. Mr. Paul can do something. It's okay.
For the interest of time, I think that suffices. Next presenter, please. Florence, you have some questions?
Yes, thank you. First, thank you, Dr. Ashinafi, for your very good recommendation. I will take that into consideration. And Mr. Luke, thank you for your opinion and the question. I totally agree that the total knowledge is needed for promoting biodiversity conservation. But my next steps in this study now will help me to come up with a definitive conclusion to develop a framework that will promote biodiversity conservation and develop ecological knowledge, and particularly within protected areas. And for starting with, I think with plant taxa as for the basis, it's okay, but I agree with you that we need a total knowledge. Thank you so much.
Thank you very much. In maybe 1 minute, presenters, if you have anything to say to the audience. Anyone?
Okay, thank you very much for the nice question. I have been asked about the motives which made me to include the environmental variables while the study area is lying about in the same attitude. Actually, that is the nature of the plant is not only affected by the environmental variables, rather also is affected by land use types. So we know that in Kisongo there are the Maasai ethnic group which their activity is agriculture, while the Meru ethnic group mostly they are doing agriculture. So also these values send us or sent the study to be done in these two study areas. And the vivid results showed that in Kikwe had 23,600 density of this euphorbia heater, while in Kisongo had 760 euphorbia heater. That marks that maybe due to these activities are letting the difference in the availability of euphorbia heater. Thank you very much.
Okay, thank you very much. We have another 1 minute. If I'll give one privilege. If anyone have a question to Mole or comment. If there isn't, then I'll give Mole half a minute to say something.
One question, please.
May you give a statement to wind up? Okay, thank you.
Thank you for a nice and very well structured presentation. Sorry. If you were to continue this type of research, what would be your next steps?
Thank you for the very constructive question. I would like to continue or to focus on existing harvesting practices and the indigenous knowledge associated with the conservation of the species.
Thank you very much.
Okay. Ladies and gentlemen, another round of applause to our presenter. And a big round of applause to all participants. Thank you very much for the opportunity to be the moderator for this very interesting session. I believe now we can say broadly that we will soon have a good group of young population with very good knowledge of business, knowledge and native way to conserve our biodiversity. So thank you very much, and thank you for your active participation.
I think you're remaining behind because you still have.
Thank you. This has been, I think we are very on session. You still have to take us through the second round of presentation and the question and answer session. Please.
Okay, thank you very much. Let us go to another session of presentation, and I'll be calling the presenter. The presentations are ready. Great. Our first presenter is Gilbert Mush. Please welcome on stage. Gilbert, you have 15 minutes of presentation.
And I understand Gilbert also has a demonstration part, so he has to spend a few minutes in the oral presentation and then take us to the demonstration part.
Gilbert, you may want to save time. Within 15 minutes, get the whole good package to the audience.
That's right.
Good afternoon, everyone. My name is David Mushi, and I'm assistant lecturer at the University of Agriculture. I'm also a third-year PhD student at the University of Geneva, and I'm doing a multidisciplinary project on developing an information system to help smallholder farmers again sustainable agriculture. So Flutter framework, of which listeners can be accessed in all platforms, iOS, Android, and the web technology, so any kind of device can be used. So this marks the basis of our service, the basis of our platform, is the farm and farmers data. This data now is the one that will interact with the key stakeholders for the sectors. For example, the financial, the market, and advisory and all other sectors. We will collect this comprehensive data comprising of personal, communication, location, farm, field, and all financial instruments, credit information, insurance. So these are categories, but we have different levels of data to make it very comprehensive. Now, financial services. So since we have this comprehensive data, now we can, the farmer can, if the farmer is already in the system, can request any service and get the service promptly using the data that are available. So you can imagine here using the API, which will be able to exchange data between the platform. And we shall demonstrate this. All these services shall be demonstrated. We have advisory service. In our survey, we identified that most farmers use their own knowledge to conduct farming, which sometimes is not very good as they get low yield. But they are doing this because they lack information. We are doing that. We are doing this to also include services like advisory services, where they can also get some advisory experts. They can search repositories. They can ask questions from experts and get the knowledge which they can use for production. But with market services, just like I told you, the farmers will be able to post their farm products so that they meet the potential customers directly, eliminating the middlemen. The middlemen are consuming a lot of profit from the farmers. They don't do anything. They wait for the farmers to harvest. They know where the market is. They go to the farmers. They take it very cheap, leaving the farmer poor, then going to profit in the market. So by doing this, we are linking farmers directly with the data processing industry and other consumers. So this is to say that the implemented set and demonstrated farmers access to financial, just like I presented before, but the focus here is on the impact of this digitization, sustainability. So the farmers will be able to get economic sustainability as they improve production and income, but also environment. For the environment sustainability, just like I said, they are using some standard farm inputs, which sometimes the government have abandoned them, but have banned them because of their effect to the environment. But using this system, we can manage the holistic of standard farm inputs. In conclusion, I will just say that this platform is designed for Tanzania, but I can see many places from different countries here. It is very compatible to other low-income countries because we share some similar challenges. So, just like I said, this is just a part. Other publications have also presented the other part of the as you can see from our reference. But the end of this presentation marks the 5 minutes of our demonstration. I'm almost there. So now here, the farmer will be able to log in, to sign up first. But for this demonstration, we use the account that has already been created to log in. And after login, automatically, this will be open for all. So after login, we will see the marketplace, where you see the posted items by the farmers. So that anyone who is interested can click on the item that the seedling, advisory of the farm machinery. But also we have a link to a repository, which is a live repository operating at the Sokoine University of Agriculture. We created a repository for the farmers to give farmers information. I don't know if anyone knows about it. So if they click there, if now we click it, it's a live running repository, which a farmer can also search the information. So that's one is the real one. It's in Kulima repository, maintained by Sokoine University of Agriculture, aimed to give farmers information and details of. But also they can also send an email to an expert about in the field. When they click on the link, they can write their email like, I have this problem and I need some information or advice. So that's perfect. This marks the end of my presentation, and thank you very much.
Thank you very much, and thank you for saving 1 minute. Our next presenter is Emmanuel Menya. Please welcome on stage. Yeah, Mushi and your colleague, you can stay. Floor is yours.
Good afternoon. My name is Emmanuel Menya. I'm a lecturer at University found in Uganda, and at the same time I'm a postdoctoral fellow at Makerere University. I'll be presenting on the topic of characterization of waste biomass from different cultivars for potential utilization in thermochemical conversion processes. Biomass is Uganda's primary energy source, accounting for over 89% of the primary consumable energy. At a household level, biomass accounts for 95% of the energy that households consume, and this is in the form of fuel wood and charcoal. Because of the heavy reliance on biomass, there's been a lot of forest cover loss, which is currently at 11.66 and continuing to decline at a rate of 1.44% per year. Because of the high forestry cover loss, government has come up with bold steps to combat the unsustainable use of biomass. And some of these steps include, for instance, last year in May, an executive order was issued banning the cutting down of trees for use in the production of charcoal. The government is also advocating for clean cooking and use of efficient charcoal production technology. which results in low emission potential. So it should have a low sulfur, low nitrogen contents. And then for economic viability of the thermochemical conversion process, we need to have biomass with high lignin content so that we get more culture and many others. The banana value chain is one of the most important crop value chains in Uganda, and it's also one of the crop value chain that generates huge quantities of waste biomass. And from the literature, we see that for every ton of bananas produced, over 4 metric tons of banana was produced. And this is majorly sugar stems, banana leaves. We have banana peels. So if we are to go by the product to revenue ratio of 4 to 1, Uganda produces about 11.2 million tons of bananas per year. So in the whole year, we have about 44.8 million tons of banana plant waste. Some of these wastes are already being utilized. For instance, some of it is used for mulching, composting, feeding animals, making crops, and so on. But because of the fear for spreading of bacterial weight and other diseases, some of these practices are not being implemented by farmers. So we have residual banana waste that are usually either openly dumped or burnt, and this causes this raises environmental and health concerns. From the literature, we see that the properties of banana plant waste vary widely depending on banana cultivar, geographic origin, climate change, climate conditions, soil conditions, and so on. So it's very difficult to transfer or to transfer one technology to another. So this is why it's important for us to characterize the banana plant waste across different varieties and gain information on how these properties vary and how we can tailor the waste to different chemical conversion processes. There's already one study that was conducted in Uganda which compares the properties of banana peels from Nyachinika and Mbazwe banana cultivars. The findings were that the properties vary significantly across the banana cultivars. So their applications would also differ. So banana plant wastes were collected from two banana cultivars, Mbazwe and Porogoma. These are some of the most popular cooking banana types in Uganda, and they were collected from two geographic ratio, which is a ratio of fixed carbon to volatile matter, was quite constant, but very low as compared to what is expected of a good fuel. So this also indicates that there's need for pretreatment of the biomass to enhance the fuel ratio. If you look at the atomic oxygen carbon and hydrogen carbon ratios, we see that all the biomass waste had very high organic to carbon ratio, which is an indicator of not very good fuel. Still, this points to a need for pretreatment, for instance, through densification, like briquetting or pelleting, and so on. Okay, thank you. And then for the mineral components, we see that the predominant elements were calcium, potassium, silicon, and magnesium. These are lead to acid-related problems that I already talked about. So there's need for pretreatment of the waste. And then we investigated the thermal behavior of these wastes, and we noticed that the wastes degrade through 3 temperature zones. But out of the banana plant waste, the fluorescence exhibited the lowest thermostability, which implies that decomposition could be initiated quite earlier than the rest of the biomass waste. And the conclusion, we see that regardless of the banana cultivars, all the banana plant waste were suited for gas and oil production due to their high oil cellulose components. And then we also see that the inflorescence exhibited the highest lignin content, which could be used for biochar production, but it's still not sufficient for an economically viable process. So for purposes of making the process more viable, economically viable, it would be wise to tailor the production of, tailor the thermal processing of these products to the co-production of the 3 products, so that we have biochar, we have the bio-oil, we have the syngas. Otherwise, biochar alone will really result in very low yields. And of course, lastly, we see that the waste exhibit high ash content, which is not good in thermochemical processing. We need to pretreat the waste. Thank you very much for listening.
Another round of applause for Imanga. Imanga, do they want to join us in our seats on stage? And I call upon Asha. Asha Kiunga, please welcome on stage. You also have 15 minutes of presentation. Please stick to the time.
Welcome to my presentation. My name is Asha Kiunga, studying Masters of Science with Education at Equal University College of Education. My title says Evaluating the Efficacy of spurt fowl in disrupting mating of the fall layman in maize in Iringa District, Tanzania. I'll take you through that outline, starting with the introduction. The Falamium is a serious worldwide pest that affects agriculture. It is located in the tropical and subtropical areas of America. This pest is very difficult in controlling because of its feeding habits, as it is a polyphagous feeder that is capable of feeding on more than 350 plant species. But among all, it prefers the Quasi family. But also it is highly migratory that is capable of traveling on 100 kilometers per night. And it is highly fecundate. The female is capable of laying eggs between 1,000 to 2,000 eggs. And that is the life cycle that shows this pest has got 4 stages, where the adult lay eggs, the eggs takes just 2 to 3 days before they hatch to larva. And the larva stage is the one that is distracting the maize. And it has got about 6 easters, 1 to 6, but the 4 to 6 one are the highly destructive compared to the low easters. As I said, this is a significant pest for the maize species, and it is capable of destructing the maize at all stages, starting from seedling emergence to ear development. The first picture there shows the vegetative part of the maize that has highly been destructed by this pest. But the second picture shows the reproductive part of the maize that is also destructed by the fall army, but it also has the cob. You can see the blood there. It is distracting the cob, but also it affects the grain. And this created threats to the people, as about 300 million of people in Africa will depend on maize for staple food. The estimation losses worldwide is estimated between 80 to 20 million tons of overall production, but in Tanzania it is approximately 3 million tons are lost due to this pest. The economic value that is associated with this infestation has direct effect to the agricultural production, but also the effect on the international market. Since the emergence of this pest, the African government has just adopted the chemical use of the insecticide to get rid of this spread and infestation of this pest. But meanwhile, this pest has the ability to develop resistance towards the insecticide that are used, such as the pyrethroid, the organophosphate, but also these chemicals that farmers adopt to use because of the resistance this pest develop. They make farmers to adopt it for the highly toxified chemicals, and this creates an effect of the health for those growers, the consumers, but also the environment at large, because the destructive and the beneficial insects that are around the area. But currently we have this biotechnical approach of synthetic pheromone that is used in getting rid of this pest. But in African countries, there are few studies that have been using this synthetic pheromone in controlling, and most of them they have just used it for the monitoring purposes in mass trapping. But we have another strategy in using this synthetic pheromone that is mating disruption. So the aim of this study was to assess the capability of this synthetic pheromone in causing mating disruption of these falamium, so as to lower their population, not to have the lower economic injury level that will be caused. And you have the 3 specific objectives to attain the general objective, as I have started, evaluating the lineage level of maize on the list, on the maize crop, examining the abundance of the falamium, but also assess the frequency of pesticide application that the farmers will be using. And we have these 3 research hypotheses
welcome to take a seat forcefully. Another round of applause for her. Now, our last presenter for this session, Shekina. Please welcome. Shekina. Please welcome on stage. You also have 15 minutes to present your paper, and after Shekina, we'll go for a very short question and answer session, and then we'll break for lunch. Shekina, the floor is yours.
So thank you everyone. So my name is Shekina Hindai, and I'm a master's student at the National Institute of Science and Technology. And today I'll be taking you through a small section of my paper that is more about creation of awareness and the adaptation of the tool that we created during my study. So I'll be introducing you the use of the kidney disk spectrum for disease evaluation, and mostly focusing on the crop common bean. So common bean is the most important crop in Tanzania because it is used by a lot of smallholder farmers, and also right now it has also been used as a climate mitigation strategy crop, whereby farmers are replacing the use of these long-term or long-season crops like maize with beans because of the fluctuation in climate change. And so about 1.2 million tons of common beans are produced in an area of about 1.12 million acres, and it's a high source of food and income because of its high protein, fiber, and vitamins and minerals. And also it has wide ranges of interest depending on the farmers and end users of the crop. So we have the problem of continuous global changing, whereby these varieties can't keep up with the climate change. We have the consumption rate increasing due to rapid population growth, and we also have the issue of time taken to release any varieties that can adapt to both climate changes, which are prone to disease infestation, and also the ability to have drought tolerance. So we have also an issue of whereby, in order to breed for these new varieties, we have to rely on manual phenotyping. Breeders have to go in the fields and work under the scorching sun to try to find a cultivar that is resistant to maybe drought tolerance, flooding tolerance, or disease tolerance. So the common bean crop has a variety of problems. We have the biotic problems, where we have the issue of pests and diseases, and the abiotic problems, where we have the soil fertility, mineral deficiency, and water stress. So our tool was focused mainly on the evaluation of the common bean disease called angular leaf spot, which is a foliar disease. And so the problem is, as I've stated before, it is being evaluated by the use of the naked eye. So we are proposing the use of the scan spectrum, which is also developed by a company called the QE, to help in promoting and developing varieties that are stable in multiple environments. So this research was conducted in 3 regions: Babati, Bukoba, and also Mbeya. So throughout, when we went to talk to breeders, like what would they want in their tool, what things would they want for them to be able to adapt that certain tool, these are the answers that popped up. And the winning answers were the above 3. The first one was that we can't adapt these tools because of limited infrastructure and capacity building, also cost and affordability, and also the diversity of African crops. So another were institutional support and also social cultural function, where traditional practices and perception influence the adaptation of different tools that have been introduced to breeding programs. So solution that will overcome the manual phenotyping by having these characteristics. It was able to have RGB observations, spectral observation, digital data collection, accuracy, biochemical observation, analysis, and also data security. So today I'll be introducing to you the tool that we developed, and we hope to be adapted by breeders in Tanzania. So we have a tool called the Scan Spectrum, which is a VIS and NRI portable tool that it enables in situ agriculture and environmental analysis at scale. So it addresses the high benchtop lab instrument, so it is very cost effective, and also it is addresses the logical cost of drawing samples from the field to the lab. In case of disease evaluation, for you to confirm that a certain disease that I'm observing is present, you have to go to the laboratory and do some analysis to confirm that yes, the disease that I'm working on is really present. So this tool helps reduce that time taken for you to carry the samples from the fields to the laboratory. So the importance of using, why is our tool using the NRI spectroscopy? We are using this because, first of all, it's a highly flexible form of analysis. It is cost effective, has the capability of examining irregular substances. As on this program statement, I said that the nature of the diversity of crops in Tanzania or Africa in general has really limited the adaptation of different tools or digital tools for data collection. It is also non-destructive, so you don't need to uproot or damage any of your plant, and it requires little or no sample preparation. You just go to the field and you scan, and then you get your results. So these are the characteristics of our tool. That is our tool. As you can see, it's a very, very small tool. You can just hold it on your hand, walk with it anywhere. So one of the most important things that we have to keep in mind while working with this tool is that to ensure that the tool works with an Android phone. We see that most of during our data collection and also interviews, we saw that many of the breeders in Tanzania work with Android phone for data collection. So when developing the tool, we had to keep in mind that we have to use Android phone so that it is highly adaptable. So it has a spectral range of 400 to 1000 nanometer, resolution of 3 nm, and also measurement time is only 4 seconds. And the spectral image size is small, around 1920, and it has two working modes, transmitters and also reflectance. Transmittance is used in wet samples, and reflectance is used on dry samples. And also it is very light. You can just put it on your backpack, go with it everywhere. And also it can operate in high temperatures, so you can work with it anywhere without being afraid of maybe it will overheat or something like that. And it doesn't require to be connected to maybe indoors to a bus, maybe a cable. You just have to have a small power bank that you need to charge your phone, and you can go with it to the field. So it operates using only 3 main procedures, but I'll clarify later on the procedures in general. So you have to launch the app, calibrate the app, then scan the app as shown, the scan the plant as shown on the pictures. So it's not all seen, but the results produced were where you collected the data, what time you collected, who collected the data, what growth stage was collected, and also the disease severity of that plant. So it is known that breeders use a disease scale of 1 to 9, and they use that just to know the resistance, susceptibility, and the tolerance of a crop. So what we did was to simplify that. So the tool gives you this susceptibility rate, the resistant rate, and also the tolerance rate. But we do not hide the original cause of the disease. So if you are not not satisfied with the answer, maybe you said maybe resistant, and I'm trying to see its tolerance. We give you the scores, the minus scores of 1 to 9. You can compare, and then you can be, oh, okay, the tool is performing great. So why are we interested in promoting the use of the equidistant spectrum? So it is less expensive than most benchtop laboratory. So it can take images that can be taken, if you know, by a machine called a T4. And a T4 costs thousands and thousands of dollars, but our tool costs around 500 USD. It is adaptable. You can play with it. You can either choose to work with it in the laboratory, in the field, collecting data on water samples, collecting data on soil samples. It's just how you integrate with the tool. It is easy to use, as said, in the fields, and also it requires just to be mounted on there with a power bank and a smartphone. So I already said interoperable because the scans are recorded in open machine and readable formats, and can be opened and shared across breeding session. It also reports both the spectrum and NBVI in seconds, while to save the georeference data, which is very important in breeding for cultivars that are stable in multiple environments. And also it multitasks, as I said before. So these are a few uses that the spectrum can be used for. The first one is reflectance, scanning the leaf to know the disease, chlorophyll content, also stomata, the number of stomata present on a unit area, and also it can be used to calibrate bacterial concentrations in the field. And also we have tried measuring the nitrogen content in the soil, and it has worked so far. And also we can measure the chloride content in water samples. So in conclusion, is that digital phenotyping has the potential to improve efficiency and accuracy of plant trait and characterization. We just have to know which digital tools work well in what context. And also, the use of NRI-based spectrum devices can capture more detailed information, and the key here is detailed information and not accurate information. We are using a low-cost tool, so we are trying to just get good enough data that can drive decision-making in breeding programs. So it also can be complemented with information from other sources. For example, you can use your camera to capture, where we get RGB-based pictures, and you can use it to analyze. Then it is of very importance to help in improving phenotyping and ultimately the plant breeding. So thank you for listening.
Thank you, Shekina. Please welcome on the stage. Members, another round of applause for her. Thank you. Now the question and answer session is open, very brief, straight to the point. I believe you, the presenter, and myself are going to make sure that we go for lunch before 2 p.m. Question? I see the hands. 1, 2, 3, 4, 5, 6. 6 questions. We'll take all the questions, and then for the interest of discussion can continue over the lunch table, but we will hear all the questions.
Okay. Thanks for this chance to ask some questions to Mwishi. I'm Stefania from Saving Africa's Nature. And I really appreciate the presentation of you all. But I have one question, because my friend was talking about the introduction of the portal, to help the smallholder farmers on their crops. So I have one question. First of all, it seems like you're not appreciating the importance of middlemen in this system. But I have one question. According to your survey, maybe, what plan should be done with the farmers that are interior to get us smart to support this portal? And also another question, to the designated portal, approximate, the designated portal, it support what kind of activities that it support? Maybe it support maybe even the price. How about negotiation of the between those two people? How the portal support? And also sometimes the traders, they want to see the sample of the product. Does the portal also support this?
Thank you. Next question, please.
Please be brief and straight to the point.
Thank you very much to all the presenters, and I'll ask 5 questions to one presenter to represent all of you. The question again is to Gilbert. Thank you for your system. I wonder whether you should call your system an information system or a portal, because the two are different. Secondly, your motivation is also partly based on the work by, or the literature review by Mushi and others of 2022. And one of the issues that they raise is the sustainability and the lack of a system that addresses the complete farming cycle. So if you call yourself people who are designing a digital information system, to what extent does this system address the whole farming cycle? Because I might have missed it in your presentation, but I didn't see it. And then the third question is how sustainable is the system? And what would be the difference between a simple WhatsApp group with this system? Because I know in a WhatsApp group I can post information requesting for whatever information I want. I can even put my products and I can still get buyers. So what will be the difference between the system? What will it be? How different would it be to just a simple WhatsApp group that I can put together? Finally, you say that your system also has got an email functionality. Did you think about putting a chat functionality so that we can have real-time response to whatever problems we have as farmers? Thank you.
Thank you. Next question, please.
Now will be next question.
I'll be brief. My comment and question goes to Shekina. The comment is that I would have loved if your device was actually embedded with a rechargeable battery other than carrying a power bank with you. I think that would make it more portable. The question is that in your conclusion, you emphasized that your device was actually more into capturing details other than accuracy. Now the question is, in a scientific world, I think accuracy is key. How do you think you can actually improve your device to actually be more accurate in its results? Thank you.
Thank you very much for this chance again. My question is for Emmanuel Maya. And first of all, congratulate all of you for a nice presentation. But for Emmanuel Maya, what was the motivation of him to think about generating bioenergy from something which is non-wood materials, the banana wastes, instead of looking at the potentials of bananas, pseudo stem has long fibers, which if you can use just a simple art, you can make packages, materials from that with the simple art. And we know in East Africa, we have banned the plastic bags. And we need a variety of plastic package materials. So my question is why he didn't look for the potentials of banana, pseudo stem and the leaves for the long fibers to make those packaging materials, and instead looking about the generating alternative to charcoal in the fuel wood. Thank you.
Thank you. I think he got it clear. There was another question here, and the last one. Oh, yeah, please.
Yeah, thank you very much. My questions goes. Is it Kiunga? So I have got two questions. Number one, what is the foraging range of the other insect pest? And then number two, while it might be too early for you to confidently tell, but I was wondering, can you guess how effective is the technology in managing the investigated pest at field level? Thank you.
Thank you. At the middle.
Thank you very much. My name is Kis from DRC. I have one question to Asha. I would like to know if you know some negative impact of this synthetic hormone on the environment, for example, in the soil or in the atmosphere. I don't know if you have some idea about that. My second question, another question is to Shekina. It's an interesting presentation. I would like to know if possible to use this tool to improve the understanding of fish fished by the fishermen in a lake, for example. I asked this question because we have a lake nearby in my city, Lake Kivu, and we have 15 species which all are endemic to the lake, and they are morphologically related. So I don't know if the tool can be used to improve the management of these 15 endemic species.
Thank you. Last question on the other side.
Thank you very much, moderator. My question will go to Gilbert Mushi on your technology. I'm just curious to know your innovation focuses to help smallholder farmers, but we know for sure that most of the smallholder farmers don't have this smartphone. So how are you planning to take further this innovation to help the smallholder farmers to get access to market, also to credit scale? Thank you.
Okay, thank you very much. That shows it was really quite an interesting session of discussion. Now, for the interest time, I'll give each presenter to respond to only one question of their choice, for the interest of time again. And other questions you can engage during lunch break and continue for the discussion and clarification. So presenter, please choose one question and respond to it. Thank you. Welcome. Where should I start? Yeah, from the beginning.
Thank you. The question was why non-wood materials? And as I said in the background, that in Uganda, the government is encouraging turning away from the unsustainable use of biomass, traditional biomass. So we are looking for alternatives that can offset or replace the use of fuel wood and charcoal. So one of the alternatives is to use agricultural residues. Theoretically, any biomass can be used for biofuel production. It's the target product that that determines which biomass to use. So the aspect of using the banana plant waste for making packaging materials is possible, and people are already doing it, including production of bioplastics. Yeah, but our focus is on utilizing the waste for biofuels. Thank you.
Thank you very much. Action. One question, be brief, please.
Okay, thank you. Can I respond to the sick about the effect of the specialized pheromone law and application technology, their effect to the soil and the environment? These pheromones are said to be species specific, but they are non-toxic to the extent that their effect that is present is very low, and it is odorless. It does not affect even those farmers that are present to the farms when it is applied. I don't know if I've answered the question.
Thank you. You have. Next. Moshi, one question.
Yeah, I'm choosing this question because it was asked by two people, and the question was, how do I plan to distribute the smartphones, especially in the remote areas and all that. But for your information, we conducted an interview and a questionnaire as a survey to 13 regions in Tanzania, and this included the remote areas. Mostly we concentrated there because we know the challenges, but you should be sure that the infrastructure is going very well with the electrification of the project in the country, the electricity is there, and the communication network is there, but there are still some challenges. On the devices, we asked the farmers, one of the questions on the survey was, will you be able and will you be willing to use the devices, and will you be able to buy it? They said, yes, we'll be able to buy it as long as this platform will be helpful to this extent. So you should not be worried of their capacity of, or their ability of buying the smartphone. What they need is the platform so that they gain the advantage of the platform. Otherwise, for the sake of Professor Ngube, this is not a bottle, it's an information system. That's why I should put it here.
Thank you. Next, Shekinah, please. One question out of two you have. Choose one.
So the question that I'm choosing to answer is about the accuracy. So what I said was we are providing good enough data. For us to provide 100% accuracy data, we have not to add the cost. We have to have high spectral cameras, and these high spectral cameras cost thousands of dollars. We can't make a high spectral camera. We can make a very high high phenotyping tool, and a tool that can
Thank you very much. Ladies and gentlemen, allow me to welcome you and to give a round of applause to all the presenters and to all of you who have been very active in this discussion and all the questions that has been asked. Please. Sorry for the interest of time, all the questions were really interesting, and I urge you to please continue this discussion, and I believe they are all recorded as in the proceeding of this conference. So thank you very much. Back to you.
Thank you very much, Dr. Nyambiliwa, for leading up this session to this point. This was really a long session. I appreciate it. Please, you can go back to your seats. And ladies and gentlemen, now we are going for lunch. And I'm expecting you to be back here by maybe after 40 minutes. It should be enough. So at what time now? It should be around 2:40. Yeah, around 2:40, 2:45. So we go quickly and get our lunch. I hope we won't find a long queue as happened yesterday. So we'll be back here at 2:45, ready for closing ceremony. Thank you very much. Have a good lunch.
Ikawa suka tu boleh kan sana. Dia kan boleh kari guys.
Nini tena? Nini? Unalialia?
Professor Luke, please, can you sit over here? Yes. A very good afternoon. Thank you for coming back. We are going to a new and important session of closing event. This closing event will have a series of events, and I'm happy that together with us, we have the guest of honor who is already in the room, Professor Nm-Aist, who is acting DVC Academic Research and Innovation. Ladies and gentlemen, the first event is the guest of honor will be giving the prizes to different people, different groups. The first group will be a group of keynote speakers who will be given a trophy for their participation. Allow me to bring Mr. Robert. Please, all right. Allow me now to welcome the high table to stand up and to offer the trophies to the following group, which is a group of keynote speakers. I will start with, can I have also Joyce here? At the stage. Quando é bastante poder usar. Thank you. So the first person to receive the trophy is Professor Ron Swain. Professor Ron Swain gave a keynote speaker. I think he was, I don't know, was he the first person? Please, if you're around, please come forward. He's not around. Thank you. Maybe someone to represent. Yeah, thank you. So, oh, okay. So Mr. Stanley is receiving a trophy for Professor Ron Swain. Thank you. The next person in the group is Professor Rob Mehta. He's not around. I welcome should be Professor Didas Kimaro. You should be clapping at least. Yes, we appreciate the mind-provoking speeches that you guys gave. Thank you, Professor Kimaro. Apart from giving speeches, apart from giving keynote speeches, they were also involved in moderating some of the sessions. Next is Professor William Blake. William Blake, Martin, then Joyce will be receiving that for Prof. Will. The next person in the group happened to be also in the stage, like in the high table, is Professor Luke Brandon.
I hand it over to Dr. Greit Nelson.
Dr. Greit Nelson will be receiving the makofi mengi kwa Dr. Nelson. She gave a very nice speech this morning. The next speaker is Professor Caroline Njau. Professor Njau, not in the room. Maybe someone else to represent. It could be his student. Jerome? Thank you. Thank you. In the same group, we also have Dr. Renatus James. Dr. Renatus James. Someone again to represent Dr. James Renatus. Thank you, brother. And last but not least, I have Professor Patrick Ngulube. So Professor Patrick Ngulube was one among the very active participants with lots of questions to almost every session. Thank you. Thank you very much. The next group, ladies and gentlemen, is the group of sponsors who will be awarded the certificate. The first one in the group is a representative of Real UOS. These are the guys who made this event possible. The next in the group is Nawiri Foundation, representative from Nawiri Foundation. Then Joyce to represent again. The next is Ngorongoro Conservation Area Authority. They are not here. The next one in the group is Grumeti Fund. Grumeti Fund. Next is CRDB, representative from CRDB. The next is a representative from Wise Future. Wise Future, Dr. Moyo. Next is Oikos East Africa. And last but not least, is NMB. Thank you. The next in the group, thank you. The next in the groups of certificates, we also have certificates to the co-organizers. So I call the representative from KU Leuven. Last but not least, in the group we have Mwenge Catholic University, Mwekao. Makofi mengi kwa mzee Kimau. Asante sana, makofi mengi kwa wote waliopokea zawadi na certificates. Na ni waruhusu meza kuwa kale. Dear participants, the next event is we are going to listen to the conference resolutions that will be delivered by Professor Linus Munishi, who is also the chairperson of the organizing committee. Professor Linus, please.